Hello everyone. Today I am going to discuss one problem from CSES problem set which is longest palindrome, and along with this I will discuss one string algorithm which is Manachar's algorithm. So what is the problem? So we are given a string and our task is to determine the longest palindromic substring of the string. For example, the longest palindrome in the string AYBABTU is BAB. Okay. So here let's take one example. Let's say we have something like ABCBAB. Okay, ABCBAB. So here are two substrings BCB and BAB, which are palindromes. I am not going to explain what palindrome is. It is when we read from front, it is same as when we read from back. So longest palindromic substring of length substring is of length 3, which is either BCB or BAB. Now we have to solve this problem in order of n, because n is 10 to the power 6. There are other solutions where we find all the possible palindromic substring with some dpl2r, and dpl2r we find that if l2r is a palindrome or not. dpl2r would be 1 or 0, and dpl2r will be nothing but is still equals to sr, and we can say and dp of l plus 1 r minus 1. This is one common algorithm, common dp algorithm, where we solve the problem where find all the possible palindromic substring in order of n square. So this approach is not possible here because the time complexity is order of n. So how we are going to solve this problem? We are going to solve this problem using one algorithm which is called as a Manachar's algorithm, and this is quite popular algorithm. So what Manachar algorithm does? Manachar Manachar algorithm finds all the possible palindromic substring. What this algorithm does in order of n. Okay, it finds all palindromic substrings in order of n. How does it do? So it builds one array. We can call it man array. You can call it man array, or which means that what is the length of the palindrome centering at this index. So let's consider ABA. Okay, ABA. So what is the length of the palindrome centering at this index? What is the maximum length of palindrome centering at this index? We can take only one left part. Okay, so the left part has length 2, so we can call it that the maximum palindrome starting from this index is nothing but 2. Okay, now let's take something like ABCBA. Now here there are multiple palindromes, length 1 palindrome, length 3 palindrome, length 5 palindrome, centering at this index, but we have to find what is the maximum length palindrome centering at this index. Okay, which will be 2, 3. Okay, right, 3. So we can call it man of man of the third index is 3. So this is to find this man I in order of n. So we are going to find man of I in order of n. Okay. Now this is solvable for odd length palindrome, right? Here we are finding odd length palindrome, but there are some cases where there are even length palindrome, right? Let's say EBBA. So EBBA, the palindrome does not center around any specific index. Okay, this this does not have any center. It has two centers, right? This one and this one. So Manachar's algorithm will be unable to solve this type of even length palindrome. That's why we will pair this string with some special characters. Okay, so let's say we are starting this string with some dollar. Okay, we are starting this string with some dollar, or let's say hash, or same thing. So we'll start this string with hash, and after that we'll use some delimiters between each and every character. So a dollar a, and let's say we are using delimiter dollar. Okay, hash a dollar, then b again dollar, and then again b dollar, and then again b dollar, and then again a, and let's say dollar. Okay, so so hash and dollar is that the starting and the ending characters are not same. That's why we are using this. So now uh, after that we'll find the same man array for this. Okay, we'll find the same man array for this. So this will be 2, because we have something like a dollar. This will be what? This will be 4. So this will be 2 4, and this will be what? This will be this will be I think so. So I have taken one extra b. That's why it is not working here. So let's take one lesser b. So let's say dollar hash a dollar b dollar b dollar a dollar. Okay. So this will be length 2, so this will be 2 here. Now this will be of length 4, this will be 4 here. Now for this dollar there is no match, okay, so this will be 1 and this will be 1, okay, that's why we have 2 4 1 1. So we'll just consider strings centering around dollars, okay, we'll just consider strings centering around dollar. So now when we get 4, that means we have 4 length here. So if we take 4 by 2, we'll get our desired answer. I hope you get it. So if we take 4 by 2, we'll get our desired answer. Okay. Now let's go to the Manachar algorithm. How we build this man array. Okay. So this is man array, right? This is man array. How we are building this man array in order of n is the important part, because after that the algorithm will be straightforward, right? So we'll find the maximum value of man from we'll construct the man array for both odd value and even value. Okay, we'll consider the man array for both odd value and even value, and then we'll try to figure out what is the maximum length of substring we can form centering around the current index. Okay, so this is the solution, but the main problem is that how we are going to find man array in order of n. Okay, so I will refer the Manachar algorithm in the CP algorithms article. Okay, so how does it do? What is the brute force solution? Okay, so brute force solution is that we will initialize one man array or p array with all of them as 0. Okay, all of them as 0. Now what do we do is that this is a brute force solution, right? So let's say we have something like ABC, ABA. So initially this will be let's say B array is 1. Let's say P array is initially 1. So we'll check the current index. So I minus Pi will check while is of I minus Pi is same as is of I plus Pi. We will just increment the value of Pi. While this condition satisfies, we will increment the value of Pi. So initially this and this character will be checked. Now when they are same, we will just increment the value of Pi by 1. So now we will check this character and this character. Let's say there is some C here. So we'll check this character and this character. Let's say now here there is D here and there is B here. So this will not match, right? So we will break. So the length of the Pi value will be, Pi is incremented twice, so Pi value will be 3. Okay, 1, 2, 3. Okay, I hope you get it. This is the brute force solution. The brute force solution is order of n square, because we are for each and every index we are incrementing the value of Pi. Okay, let's say there is a special string with n is, okay, there is a special string with a n times. There is a special string with a n times. So for each and every string, we'll just iterate over the entire string. That's why the time complexity will be around order of n square. So this is not helping us, because we will solve this problem in order of n. That's why what we have told. Now we have to optimize this algorithm. How we are going to optimize this algorithm is again using the same technique we used in the Z algorithm. I will provide the link of the video where I have explained Z algorithm, and this is the same technique. So what is the technique? What is the technique is that we will take the maximum range. Okay, we will take one range. When we are iterating over the array, we will try to create one range L to R. So in this problem, L to R means that there is a palindrome from S of L to S of R. Now if I greater than R, we will just use our brute force algorithm. If I greater than R, we will just use our brute force algorithm. But if I less than R, if I less than equals to R, that means we have some special thing in our hand, because this is matching. Okay, so let's take this example here. Here you can see that the palindrome is centered. Okay, now this is L to R, right? This is L to R. The string is from L to R, and here we are trying to find for the Pi value for the S of I. Okay, S of I. Now, as this is a palindrome, we have a mirrored image for this current index I. We have a mirrored image for this current index I as J. Okay. Now, how to compute the value of J? Now, we are saying that there is a mirror written here, and we have to find I, the mirror image of I as J. Okay. Now, what is the mirror? Where is the mirror written? So here it is from L to R. So the mirror will be at L to R by 2, right? L plus R by 2. Now, what is the distance from I to mirror? I to mirror is the distance is I minus L plus R by 2. Okay, I minus L plus R by 2. The distance from I to mirror is L plus R by 2. Now we will just, there is same distance twice. So we have to subtract the entire distance from I. we have to subtract I minus L plus R by 2, the distance, into 2. So after doing that, we will get this is J. So J will get J will be R plus L minus I. Okay, that's what it is written here, that J equals to L plus R minus I. Okay. Now there is a case when the p value of J exceeds the L range. Okay, the pj exceeds the L range. Okay, and similarly I plus pi will exceed the R range. Okay, that's why we have to take similarly what we have done for the Z algorithm. We have to take the minimum of L minus J or I minus R, you can take. So you have to take once again we have to take minimum of R minus I. What is the algorithm? You have to take minimum of R minus I, comma P of L plus R minus I. So P of J, comma R minus I. You have to take minimum of R minus I, comma P of R minus I plus L. Okay, and the rest of the part is straightforward. This is the brute force algorithm. Now, after it is done, we'll check that if I plus Pi is greater than R, that means we have to increase our L and R value. We have to increase the range. That's why L will be I minus Pi and R will be I plus Pi. I hope you got it. Now this is the Manachar algorithm for odd. Similarly, for even, I have already explained. We will build another string like this, and we will find the even length also. Okay, I will provide the link of the article. You can go through, and the overall time complexity is order of n. You can read about it. I am not going to explain that. Now let's jump into the solution. Okay, so let's go into the result section. Now we'll jump into the solution. So here, this is the Manachar algorithm. I have already explained. Now, after getting the Manachar algorithm for odd and even, so for even, I am building the string ds, and for odd, I am using the a string only. So, odd is Manachar of s, and even is Manachar of ds. Now, we are taking maxi as 0 and max index as 0. Okay. Now, the total length of the palindrome. So, after building this, I think I have built here. ABA. So total length of the string is 2 into odd I minus 1. Here it is 2. So the length of the string is 2 into odd I minus 1. That's why we are doing if 2 into odd I minus 1 is greater than maxi, we are initializing maxi as 2 into odd I minus 1. And after this iteration is done, we are storing answer as max index. So we have to take max index. This is, let's say the index is 1. So we have to take 1 minus uh, 1 minus 2 plus 1, right? 1 minus 2 plus 1. So this will be 0th index. And what is the length? The length will be 2 into odd I minus 1. So we have to take a substring from is dot substring from is of 0 to 2. Okay, that's what we are doing here. So this is done for the odd part. Okay, this is done for the odd part. Now we are coming to the even part. Okay, so for even part, we are only checking the dollars. So dollars are present at 0th index, 2nd index, 4th index, like that. We will not check the original characters, right? We'll check the dollar or hashes. Okay, you can start from 2 also. Also, if even I, the length of the string will be even I. Okay, the length of the palindrome will be even I. So if even I greater than maxi, we are storing maxi as maxi equals to even I, and max index equals to I. Now, if max index is not equals to minus 1, so we have found some odd length palindrome, even length palindrome. We'll store yeah, we'll store answer as is the substring. What is the value of the even length starting index of the even length palindrome? Here you can see that this is 4, right? This is 4. Okay, so that means we are at this position. If we take this is current index, this will be, let me take it here. Let me write it again here to make you understand. Let me delete once, and then I'll try to explain it again. So let's take a smaller example. Let's say we have something like BB. So after padding, it will be like hash B dollar B dollar. Okay. Now what will be the indexes? This will be 0, 1, 2, 3, and 4. Now if we are this particular index 2, okay, if we are at this particular index 2, we'll take 2 by 2. Okay. So in the S, if we only consider a string, the a string is BB, right? So we'll take is of max index by 2, okay, minus even of max index by 2. Okay, that will be our what I can say, that will be our starting index, right? So if we take 2 by 2, 2 by 2 will be 1 minus the even length will be a 2. Okay, so 2 by 2 minus 2 by 2, we will get our desired answer at index 0. So we start from 0, and after that we'll take even of max index. So even of this will be 2. Okay, so we'll take 2. Now if 2 is, if there is the even of some index is odd, so the we have to delete the parity of this, because the length of the even length palindrome will be always even. That's why we, if some length is odd, then we have to subtract the parity from here. That's what we are doing here. I hope you got the explanation what we are doing from the for the even string. This is only the tricky part. Otherwise, the odd part is quite straightforward. uh, Please rewatch this video if you don't understand this example, and also you can take some other examples also and try to write on the algorithm. If you have any doubt in any part of the explanation, you can always ask in the comment section. I will try to reply each and every comment. I will provide the link of the problem code and the Manachar algorithm article in the description box. You can check that out. If you find this video helpful, please like the video and subscribe to my channel, and also share among your peers. Thank you.